Hi, welcome to this video. In this video, we are going to see about magnetic reluctance. Magnetic reluctance is one of the important term in the electrical machines. That is, it is playing a main role in the electrical machines. So that is why we are going to see further about the magnetic reluctance in this video. Yeah, magnetic reluctance is also called as magnetic resistance. It is one of the property of the material which is used in the magnetic circuit. So in the magnetic circuit practically we are using several material, particularly in the electrical machines we have stator and rotor. In rotating electrical machines we have stator and rotor. That material is made up of steel, iron, okay. So that material, and in between the stator and rotor we have air gap. So the combination of stator, rotor and the air gap, the total entire circuit is nothing but magnetic circuit, because the flux lines will travel from stator to rotor. Wherever we are giving electrical energy, then that particular place magnetic flux lines will develop. That developed flux lines will enter into the rotor through the air gap. So wherever it is passing, that entire region is called as magnetic circuit. So in the magnetic circuit, the material, whatever material we are using, each material is having some self property. Particularly, the magnetic material is having magnetic property. So that is only given in the second point. And this property is having some important character, that is, it will oppose the passage of flux lines. Okay, so it will oppose the passage of flux lines. Which one will oppose? Magnetic reluctance. So magnetic reluctance and the magnetic flux lines is inversely proportional. Okay, because it is opposing nature for the magnetic flux lines. So you have to see the formula. Magnetic reluctance equal to mmf by flux. It is the Ohm's law for the magnetic circuit, where mmf is nothing but magnetomotive force. So the reluctance is directly proportional to magnetomotive force and inversely proportional to flux. Okay, and in the electrical circuit, resistance formula equal to EMF by current. It is the Ohm's law for the electrical circuit. Both the Ohm's law, in the both Ohm's law, each parameter will analogous. That is, reluctance analogous with resistance, mmf analogous with emf, flux analogous with current. So according to this, from the magnetic circuit Ohm's law, we can say the reluctance, if the reluctance is more, then it will reduce the flux lines. Okay, the flow of flux lines will be less. Okay, so if the reluctance is more, flux will be less. But in the rotating machine, to improve the flux lines, we need to reduce the reluctance. How we have to reduce the reluctance? By adjusting the design parameter. So for that, separate formula is there. So this is the design parameter formula, S equal to L by A mu. Okay, where L is directly proportional to reluctance and A mu is inversely proportional to reluctance. Where L is nothing but mean length of the magnetic circuit, and A is area cross section of the magnetic circuit, and mu is permeability, where mu is product of mu naught and mu r. Mu naught is permeability of free space. That value is 4 pi into 10 to the power of minus 7 henries per meter. Mu r is relative permeability of the magnetic material. In the magnetic circuit, so to explain clearly, I have taken the diagram. In the left side diagram, there are 4 rectangle box in the upper side. Again, the 4 rectangle box in the bottom side. Okay. So in this diagram, you have to see, to tell about stator and rotor, have taken like this. So you may take upper side rectangle, 4 rectangle, stator or rotor, and again if it is stator, and the bottom side rectangle will be a rotor. Okay. So if you are giving supply to the one portion, that portion is completely going to get magnetized. When that magnetized material will generate the flux lines, that flux lines will enter into the next magnetic material in the rotor, okay, through the air gap. So while traveling the flux from one portion to another portion through the air gap, the entire region is called as magnetic circuit. So in the formula where L I have taken, L is nothing but mean length of the magnetic circuit. Mean length means from magnetic circuit this portion to this portion. So here to here. Flux lines are traveling like this. This is the mean length. Okay. And area of cross section means area of cross section of the magnetic circuit. Here, how much portion is linked with the stator and the rotor? How much portion is linked? This much portion only linked, right? And the second diagram, it is going to align. The rotor is going to align with the stator. So, the most of the portion is aligned. So, flux lines will be more compared to this. And again, here, third and fourth, it is exactly aligned. So, that is why flux lines will be more. But depending upon the width of pole which is taken in the stator and rotor, that say that portion only linked, okay, that portion only linked and that portion only allowing the flux lines. Area cross section is less means reluctance is more, because both the terms are inversely proportional. And if the reluctance is more, then flux will be less. That is why we are getting less flux compared to the right side diagram. In the right side diagram, area of cross section which is linking with the stator and rotor is more. Okay, by using the pole shoe concept, we are getting like this. Then the reluctance will be less, and the less reluctance will improve the flux. Okay, so this is the concept, and the important of pole shoe is, according to this video, we may get idea of reluctance. Okay, because that is the pole shoe will reduce the reluctance. And another reason is also there, that is it will give the mechanical support to the winding which is wounded over the stator and the rotor. Okay, we are going to wound the winding around the teeth of stator and the rotor. So this extended portion will give the mechanical support. That is also one of the reason. But the main reason of using pole shoe is to reduce the reluctance. I hope you are all understood this concept from this video. So if you are like this video, you have to click the like button, and if you have any queries or comment, you have to give your comment in the comment box. And if you like this video, you have to please subscribe this channel. Okay, thank you for watching this video.